All right, so we have that the first part, I'm going to move this up a little bit. We're going to be asked to find the equation of a tangent line for the function, and the function's already given. So f of e to the squared power would give me the point. So I'm going to do ln of e squared over e squared. Remember, this power can come into the front, so I get 2 ln of e over e squared. But remember that ln of e is 1, and we get 2e squared. Part B, sorry, not part B, but the second part of finding a tangent line, you need the slope, and the slope is the derivative. They gave us that formula. 1 minus ln of the x value that we're finding the derivative at is e squared over e squared, whole thing squared. Remember, we just did this already, so I'm going to pull that in front. Over e to the fourth, we're multiplying those powers. We end up with 1 minus that value of 1, 2 over e to the fourth. So I get negative 1 over e to the fourth. The equation of the tangent line then is y minus y1 equals m times x minus x1. Therefore, we get y minus the y of the point, which is 2 over e squared, equals the slope, which is negative 1 over e to the fourth, times x minus e squared. So it's not the prettiest slope, but it gives you the value. It's also a really odd-looking equation of a tangent line. Part B, find the x-coordinate of the critical point. So remember, critical point definition is any time that the derivative is equal to 0 or the derivative is equal to undefined. So we're going to take the derivative, set it equal to 0. We're going to take the derivative, set it equal to undefined. And in this case, I would solve the numerator equal to 0. I get that the ln of x is equal to 1. Take e to the both sides, x is equal to e. On the right side, if I want this to be undefined, I would set the denominator equal to 0, and I get that x is equal to 0. But it can't equal 0 because if you remember at the beginning, it says that the domain is x is greater than 0. If we want to know if that critical point here is a max or a min, we're going to do a sign chart for f prime. This is 0. Remember, the derivative was undefined, but it's not part of the domain. Here's e. The derivative is 0. I'm going to pick the value of 1. I'm going to put 1 into the first derivative, which is right here. I'm only going to care about the numerator because the bottom is always positive. So my numerator is 1 minus ln of x. So 1 minus ln of x, I'm going to put 1 in. And remember, ln of 1 is 0. So this is positive 1 minus ln of 1, which is 0. So I end up getting 1. So this is a positive 1. If I put in a million, I get 1 minus the ln of, let's say, a huge number. This is going to end up being negative. So we have a maximum. And my reasoning would be that f of e equals max because f primed of e equals 0 and f prime changes plus 2 minus. Part C. The graph of the function has exactly only one point of inflection. Find the x-coordinate. So a point of inflection has a two-part definition. One part is f double prime equals 0 or undefined, and the second part is that f double prime changes sign. Okay, so we get that f prime of x is equal to 1 minus ln of x over x squared. So I'm going to find the second derivative. Low d of high minus high d of low all over low squared. Now, I'm hoping you didn't get lost here. Remember, the derivative of ln of x is just 1 over x. And the negative being there is where I'm getting this value from. So we get negative x squared over x, which is negative x, minus 2x 2x times 1 minus ln of x. And the whole thing over x to the fourth. Let's see. I could do a few things. Some of you are going to have a hard time looking at this, but I'm actually going to factor out this common x. And we end up with, if I take out an x, the first term has a negative 1. The second term has negative 2 times 1 minus ln of x. all over x to the fourth. I'm going to simplify 1 power, make that third, and we end up with negative 1 minus 2 plus 2 ln of x all over x to the third. So my second derivative completely simplified would be negative 3 plus 2 ln of x over x cubed. Critical point would happen when the point of inflection would happen when the second derivative equals 0 or the second derivative equals undefined. Second derivative equaling 0, we get negative 3 plus 2 ln of x equals 0. That's the numerator. If I solve that, I get that ln of x is equal to positive 3 halves. Take both sides to e, and we get x is equal to e to the 3 halves. On this side here, I get x cubed is equal to 0, x equals 0, but domain said that x had to be greater than 0. Our only possible point of inflection is e to the 3 halves. Therefore, that has to be the actual point of inflection because they told us there's exactly one. Letter C. This one is a little difficult. They're asking you for the limit as x goes to 0 from the right-hand side. So I'm actually going to break this up. I'm going to find the limit as x goes to 0 from the right-hand side of 1 minus ln of x. Oh, sorry, of ln of x, because we want to do it of f of x. So of f of x. All right. And then I'm going to find down here the limit as x goes to 0 from the right-hand side of just the function x. So if we think about ln of x, here's the graph, 1 comma 0. You can see that when you ride the graph from the right-hand side, you're going down towards negative infinity. If I'm looking at the graph of x, if I'm coming down from the right-hand side, I'm going to go very, very close to 0. Problem is, I'm not going to really hit 0. I'm going to be a positive small number. So, what do we actually end up with then? We end up with negative infinity divided by a very small positive number. Still gives us negative infinity, which is a limit value that does not exist. So, here is the answer key, and you'll notice that the limit as x goes to 0 from the right-hand side. 2 answers because they will accept either. If you knew that there was a vertical asymptote, which causes the limit to not exist, that would also be valid.